Hello, I'm Cathal Summers,
And I'm Deirdre Glynn,
your Teagasc Sustainability Advisors, and you're welcome to the Teagasc Environment Edge podcast, bringing you the latest information, science and opinion to improve farm sustainability.
On today's episode, we had a really interesting chat with Keith Lambkin, Senior Climatologist with Met Eireann.
Just chatting to Keith just before we had a look, Deirdre, we had a look at some predictions from the models that Met Eireann have produced, and it's kind of predicting, looking at, say, 2040 to 2060, so it's actually not that far away, only 20 years' time. And just some of the changes that some of the climate change is bringing, we're looking at mean annual temperatures might increase from 1 to 1.6 degrees, hot days to get warmer, anything up to 0.7 to 2.6 degrees, colder nights getting warmer, 50% less frost, average length of the growing season will increase, heat waves by the middle of the century, heavy rainfall events will increase in winter and autumn, storms affecting Ireland will decrease in frequency, but, and this is a big but, they will increase in intensity. So we're going to have much nastier storms in the future.
So we discussed how this is happening, the challenges, the opportunities, and how agriculture will have to adapt to a changing climate, and can we turn all of this around?
So I spoke to Keith earlier and I asked him, what's the big deal? Why are people getting excited about climate change now?
Yeah, it's a good question, Cathal. And I always kind of think that if the mountain ranges around the world were kind of looking at us now, they're probably kind of saying to themselves, well, you humans have been adding additional greenhouse gases to the atmosphere and warming the planet for the best part of 200 years. So why are you getting all excited by it now all of a sudden? The truth is that there's some very good reasons behind it. One of the biggest ones being the Paris Agreement you would have heard of, or the Paris Accord, signed back in 2015. So it's kind of important to know very briefly the background to that, because that's really the catalyst for an awful lot of conversations we're having around climate today. The Paris Agreement was a legally binding, that's important, it was a legally binding international treaty signed by the majority countries around the world in 2015. And then that led into progress, a lot of European policy and an awful lot of national policy then between the member states. Now, here in Ireland alone, we've been quite busy since 2015 with the original Climate and Low Carbon Act. And following on from that, then we had the mitigation plan, the adaptation framework, and so forth. And if we just focus on the adaptation framework in government policy in Ireland, that also led then to adaptation plans being developed across all sectors, or the majority of sectors in Ireland, and the county councils, which was a huge achievement in itself. So now we have an awful lot of paperwork. We have Paris, we have Europe, we have national policy, we have sector policy. It's now come to the point where we're actually implementing those sector policies. So action is currently being taken now. And that's why we're seeing so much more interaction with climate policy now. That's why we're seeing hearing so much about climate now. And that's why we're beginning to actually see how climate is affecting our daily lives now, is because all these plans and paperwork, all leading back to the legally binding Paris Agreement, are all beginning to be enacted, not just by ourselves here in Ireland, but other countries all around the world now as well.
And that's quite frightening, actually, because like when we're out and about with farmers, the minute you hear regulation and agreements and international agreements, we think of more rules and regulations, and it really puts the frighteners up. And I suppose the big thing in the last couple of years, climate, greenhouse gases, all this stuff is coming top of farmers, biodiversity, water quality issues. And I suppose the big thing people are wondering is, like, we always talk about the issues and we always talk about the agreements, but we kind of forget like what's actually happening in the background. We know it's global warming, but can you tell me a bit about the Earth's natural energy balance and how it's become unbalanced, I suppose, or give us a story about how is it heating up, or what's actually happening?
Yeah, okay, so let's take a step back and look at the bigger picture, okay? So over the last tens of thousands of years, the Earth was what was called in energy balance. So what does that mean? I mean, it's a bit like having a household budget. The money coming into the house was the same as the money going out of the house. Or in the Earth's case, the amount of energy coming into the planet from space or from the sun was the same as the amount of energy leaving the balance. So Earth was in this nice balanced state. Okay, so what happened then when Earth was in a balanced state? Well, you had humans, you had biodiversity, you had plants and animals, all kind of adapting to their current surroundings, the normal climate that they expect to get in any particular regions. And that's different around the world. So let's take, for example, Inuits in the Arctic. They build their houses and dwellings in a different way to, say, the tribes of Africa. Okay, you've got species that are adapted to rainforests and different species of plants and animals that be adapted to deserts. So over these tens of thousands of years, when the Earth was in this kind of energy balance or equilibrium, people and animals and plants adapted to their natural surroundings, in particular into their climate. Now, what's happening is over the last 200 odd years or so, humans have been adding additional greenhouse gases to the atmosphere. Okay, now we would have heard a lot about greenhouse gases in the past, but let me start off by saying greenhouse gases are good. So I'll say that again. Greenhouse gases are actually good. If there were no greenhouse gases in the atmosphere, the average temperature of the planet would be about minus 18 degrees Celsius, and all the fresh water would freeze. The problem is that there's a natural amount of greenhouse gases in the atmosphere, and what humans have been doing is they've been adding to that incrementally over the last 200 years or so. And that's adding as a blanket or a layer, and it's trapping more heat. And by trapping more heat, only by a small amount, what's happening is that the energy coming into the planet from the sun and the energy going out is ever so slightly out of sync. There's a little bit of energy being kept by the planet as opposed to going out. So the energy coming in is ever so slightly bigger than the energy going out. So we're no longer in this energy balance. We call it that the radiative forcing is what climatologists call it. That's now slightly out of sync. Now, only by a small amount, but that small amount is cumulative. And what it's doing is adding onto itself, adding onto itself, adding onto itself the whole way as we go along. And that's leading to an acceleration of warming around the world. Now, we should point out as well that this additional greenhouse gases, I mean, this was an unattended consequence of progress. I mean, going back a couple of hundred years ago, people figured out that burning kerosene was a good way to light houses. All of a sudden, along came burning coal worked very, very well for heating things. It actually helped protect an awful lot of lives, keeping people warm. Then along came steam power, the engine, the locomotive. From that came the car. All the time we were burning fossil fuels, but all the time it was intended for good reasons. We built our hospitals, we built transport infrastructures, all for the greater good. And an accidental byproduct of that was adding these additional greenhouse gases to the atmosphere. And I guess that's what's happened now with regards to the situation that we're in. We now realize that adding these additional greenhouse gases is throwing our energy balance out of sync. And unless we kind of correct this energy balance to plateau this warming, we're just going to constantly add to this incremental heating of the planet.
Yeah, look, and with, I suppose, like carbon dioxide lasting in the atmosphere from anything to, I think it's about 300 to 1,000 years. If we keep going the way we're going, we're kind of going to be in serious trouble, even if it's only a little bit every year. But the other thing I thought I heard you saying there before in a presentation one time is that heat that's in the earth, it's absorbed by the ocean. What happens to the ocean? It kind of frightened me when I heard you speaking about it before.
Yeah, so we release carbon dioxide into the atmosphere and other greenhouse gases into the atmosphere. Okay, so it keeps heat in. And actually, an interesting one, but one for your listeners today. So have a quick think there. What do you think is the most potent greenhouse gas? Any thinkers? Carbon dioxide, methane are ones that often kind of come to mind. The most potent greenhouse gas by a country mile is water vapor. It's clouds. And I'm sure common sense even tells you this. You know, if it's a nice, thick, cloudy night, that's typically a warm, muddy night. The heat gets kept in by those clouds. We learned that at school. That acts like a blanket. But when we ask, when on a nice, clear night, when we can see the stars, that's typically a fairly cold night. So we don't often talk about greenhouse clouds or water vapor as a greenhouse gas. And that's largely because we're not adding that in as an potential byproduct. We're adding additional greenhouse gases like carbon dioxide and others to the atmosphere. And by warming the world, we're increasing the evapotranspiration around the planet, and that's adding to it more heat and more clouds in places as well. But that's a slight aside, right? So the the oceans. Sorry, yeah. I'm just getting sidetracked myself here now. So we're heating the planet. Okay, so what's happening to the planet? And I guess this is the crux of it. Additional greenhouse gases heats the planet. That's the cause. Everything else is the knock-on consequences. So one of the knock-on consequences from global warming is that a lot of that heat goes into the land, a lot of the heat goes into the atmosphere, but an awful lot of heat also goes into the ocean. Now, we often think about sea level rise, and the cause of sea level rise is the melting of the ice caps and the glaciers. So we're adding extra fresh water to the oceans and the seas rise. So everyone understands that and it's quite clear. But there's also a thing in physics called thermal expansion. And this is, as you heat something, it can expand. And because we're heating the oceans as well because of global warming, and the oceans are enormous, heating the oceans by only a small amount makes the oceans also expand. So a huge contribution of sea level rise actually comes from the heating of the oceans itself. So the sea level rise is coming not just from the melting, but also from the heating. And it creates this kind of cumulative effect of more heating creates more oceans, more sea level rise, more melting ice, and so forth. So it's something we have to be mindful of, particularly as if we increase the amount of additional greenhouse gases we're adding to the atmosphere, there's almost a linear relationship between the amount of extra greenhouse gases we put in the atmosphere and the amount of extra heating that we get. And because, and a lot of people sometimes look over this, but because the population of the world is dramatically increasing, the needs of those individual people are also dramatically increasing, which means the amount of additional greenhouse gases we add to the atmosphere also dramatically increases. So just for an example, if we're talking about pre-industrial carbon dioxide levels in the atmosphere, for example, it took 20 decades for us to add an additional 25% of carbon dioxide to the atmosphere. So 20 decades, 200 years. It took only another 4 decades to add another 25% of carbon dioxide to the atmosphere. And a lot of that is down through increased population. And the agriculture industry would know this in particular. The population of the world in 1959 was 3 billion. 40 years later, it was 6 billion. The population of the world doubled in just that 40-year spell. So that meant the food output for the world also had to double during that spell in order to feed everybody. But it's not just food. The energy demands also doubled during that period. Dwellings, offices also doubled. The amount of extra concrete, extra steel that all had to be produced in order to build dwellings and so forth also increased. So as the population of the world increases, the demands increases, which is exponentially adding the amount of greenhouse gases to the atmosphere, which is all adding to that cumulative effect of warming. And it's that warming that causes the rising of the oceans as well as other knock-on consequences.
Okay, Keith, the Paris Agreement and our new climate action bill have a goal of limiting global temperatures increased to well below 2 degrees Celsius. So all sectors of agriculture, transport, etc. will have to sign up to carbon budgeting in an attempt to achieve this target. What effect would not reaching this have on our weather patterns? And can modelling predict what effect not reaching our targets will have on farming if we continue business as usual in 100 years' time?
Yeah, so thankfully in Ireland and elsewhere around the world, modelling has dramatically increased in accuracy and ability of future climates. And the way a climate model typically works is you have hundreds of years of past data, and there's a great understanding through research of the dynamics of the atmosphere and the oceans and the land and the cryosphere and how they all interact. So you build all that physics and knowledge into a model, and then you test it or train it on past data to prove that your model is given realistic observed outputs. Mm-hmm. And then you let that model run into the future to see what a possible future climate scenario might look like. Now, what we find is that one of the biggest uncertainties as we go forward into the future, particularly towards the end of the century, is that the biggest uncertainty becomes we don't know how much additional greenhouse gases we're going to add to the atmosphere. We have a fairly good understanding of a lot of the climate dynamics. We have a fairly good understanding of a lot of the interactions. What we don't have a fairly good understanding is how much additional emissions are going to be added by people over the next 100 years or so. So the way modelers get around that is that they create different what's called emission scenarios. And they have funny names. The current ones are called RCPs, or representation concentration pathways, and they're changing the names of them now in the next IPCC iteration to call SSPs. But for the sake of this podcast, let's just call them, rather than get into all the jargon, let's call them a high-end emission scenario, a medium emission scenario, and a low emission scenario. Now, what Paris is aiming for that we go for a low emission scenario, keeping the overall temperature of the planet below 2 degrees of an increase. ideally to 1.5 degrees.
Mm-hmm.
Now, in order to achieve those targets, there needs to be huge changes to current emission across all sectors across the whole globe. And that's why you need the international agreement of firstly all member states around the world in order to try and achieve something like this. Now, Ireland being part of Europe, being part of the Paris Agreement, has signed up to these emissions, along with, as we say, the majority of countries around the world as well. So the simple maths is to say that if the net global targets aren't met under the Paris Agreement, that means that we're no longer in a position to meet that below 2 degrees threshold. Now, is 2 degrees threshold a lot? Well, let's take a look at the last 120 years or so of Irish data. The temperature in Ireland has increased by about 1 degree over that spell. And from that, we've noticed substantial changes. So even within that 1 degree change, even here in Ireland, let alone elsewhere around the world, we're seeing changes like spring, for example, arriving earlier on average, slight changes to frost patterns and so forth as well. Now, what the physics and the models tell us is that in a warmer, as we warm more, the warmer the atmosphere, the more moisture the atmosphere can absorb. And this can create more extreme events and weather and climate related patterns. So for example, the possibility of more extreme storms is there. And we all know that it's the more extreme tail end events of storms is where the damage happens. That's where crops all get blown down, forests come down. That's where serious droughts can happen. That's where a lot of the flooding can happen. It's the tail end of the extremes is where the real damage happens across all sectors. So in a more warming world, that's what can happen. The scenarios themselves, like I say, go to a medium scenarios and right up to high end scenarios. Now, to be blunt and honest and scientific about it, the high end scenarios, I mean, they mean business as usual. So they mean the increasing population of the world continue to burn fossil fuels at the rate we're currently burning. So it was mentioned at a recent IPCC meeting, in order to achieve the high end scenario, we would have to literally go around bulldozing down wind farms around the world to reach that. And a huge amount of effort has already gone in to kind of changing practices around the world and here in Ireland to try and bring those emissions down already. But again, with regards to what scenario we end up with and how much the climate will change and then how much weather patterns will change as a consequence of that is purely down to emissions. And that's really why everyone is now really trying to put the best foot forward to try and hit the emissions that were agreed under Paris, not just here in Ireland, but globally.
Thanks, Kate. Some of us here in Ireland enjoy our wine. With rising temperatures, especially around the Mediterranean regions, vines may be harder to grow in some traditional areas. Could Ireland potentially become the new Bordeaux? It could be a new opportunity for us maybe here, especially in Wexford, where Cathal is from.
Here.
That'd be great.
Lovely.
Send me a pack of seeds, or
one of the opportunities. Yeah, listen, possibly from a climate perspective. I was at a conference on the Mediterranean there a number of years ago to do with agriculture and climate change, and there was a number of presentations from the major vineyard producers down there, and they were either investing in the climate models or doing an awful lot of analysis of the climate models to try and answer that from the Mediterranean regions. They were trying to find out that, okay, they're producing popular wine now, but in 50 years' time, will that region still be in a position to produce that same crop? And they were finding that no, it wasn't. So they're finding, well, okay, well, if this isn't, what region would be? And they were looking to try and identify regions that would have similar climatic and soil conditions as the current region, but in 50 years' time. And ideally, the end game was to try and buy up that land now while it was relatively cheap, and then slowly migrate towards that. And what the output a lot of these studies found was that typically a lot of the vineyards were migrating further north over the decades into the future. So with Ireland in a warmer position, a lot of the French wines, could they kind of start encroaching into the UK and Ireland? Very possibly. And if memory serves, I think there are already a number of vineyards here in Ireland.
Yeah,
In actual
that's true.
fact, there's one in Gorey there at the moment. So I was reading about during the week, and he's after adapting certain type of grapes that he's going to grow, and he should have the first bottles out this year or next year, I think. So we might actually keep an eye on that, Deirdre, for our podcast. But just when you mentioned, like, there is potentially opportunities, but like we can't forget that we're really hindered by at the shoulders of the year. Rain is the big issue for a lot of farming. We're always watching from, especially me and Deirdre specialise in water quality, and there's issues all the time with water quality in the springtime and in the back end of the year as well from the rainfall events. And like, by the sounds of things, that's going to get worse and potentially more droughts in the summer. So we're not really used to droughts, but we've had one or two lately, and we're watching New Zealand. They have them regularly, but they could potentially get way worse, and we could be to where they are in 20 years' time.
Yeah, and that kind of links on nicely, Cathal, as well to my next question. Keith, Ireland has a highly variable weather pattern, so it's a challenge for farmers to manage their enterprises. Has there been much work done recently in improving long-range forecasts and their accuracy as a decision-making tool within the sector?
Yeah, so if you look at what we call the climate spectrum, that spans right the way back from climate of the long past to the last few decades to yesterday. And then you start to move into the weather forecast. So what's it going to be like over the next couple of weeks? And then you start moving into the monthly forecast. And then you start moving into the seasonal forecast. And then there's a kind of bit of a gray area of kind of annual forecasts. And then you start moving into the climate forecasts. And that's kind of the spectrum. So we're fairly good at kind of saying current conditions and what it was like yesterday. We're quite good, I think, at kind of giving the forecast. And it's no secret recipe. The further you go out, the less accurate the forecast is. But over the next day or two is typically very, very good. Even here in Ireland, with hugely changeable weather. Now, one of the products Met Eireann launched recently was a monthly forecast. And a monthly forecast then kind of gives an indication. Now, when you start to get into the realm of monthly forecasts, you're no longer looking at, is it going to rain on this particular day? You start to look at signals. So you start to look at kind of bigger weather patterns that are establishing in the Atlantic. And that will give you a kind of an indication or a heads up on, is it likely to be wet? Is it likely to be stormy? Is it likely to be dry? So those monthly forecasts, which are now available on the Met Eireann website, have been proved to be quite useful across sectors. And I'd imagine are very valuable to the farming sector as well, to kind of give an early indication and a heads up. Seasonal forecasting. So seasonal forecasting is something we've been looking at internally quite a lot over the last number of years, and in particular, even the last few months. Seasonal forecasts have great success in certain places around the world. So there's certain places around the world that have very stable and consistent weather patterns to them. And seasonal forecasts can be quite good. So in particular, let's say elements of parts of South America and so forth. If we know these stable patterns like an El Nino or La Nina events are kind of appearing in the Pacific, we'd have a fairly good idea of the next number of months, what the likely type of weather patterns would be in certain parts of the world. And one of the best centres at producing these seasonal forecasts is a European centre, which Met Eireann are a member called the ECMWF, the European Centre for Medium Range Weather Forecasts. They're statistically one of the best forecast centres in the world, and they produce a seasonal forecast product. The ironic thing about it is this European product is actually very poor at giving seasonal forecasts for Europe. And that's not because the science is bad, that's purely because, like you mentioned already, Deirdre, the variability of the amount of weather systems we're getting in kind of Europe, in particular Western Europe, from all these low pressure systems coming across the Atlantic is very, very variable, and it's difficult to put together a long-term picture there. Sometimes there's a stronger signal than others, but as a general rule, still European seasonal forecasts, particularly in the Northwest, still aren't incredibly accurate. So we haven't launched them publicly yet, but rest assured that when we get to a point where we're confident in the skill levels of these seasonal forecasts, we'll be sure to provide them to the farming community.
Thanks, Keith.
Keith, I suppose the big thing I would say to you is you must be fairly sick of chatting about weather, because I know that every time I walk onto a farm, the first thing I say is, Jesus, lovely day, or grand day, wet day, soft day. It's always the first point of conversation. So I'm sure you get that a lot. But the one thing I've taken from your conversation today is that climate change is real. We can see it in the last 20 years in some of the presentations we've seen, where in the last 20 years we are heating up, and that's the way it's going. We're going to potentially have wetter springs and autumns and drier summers. So I don't think the Child of Prague will be put out of business, but it's always going to have a role. And anyone that doesn't know what the Child of Prague is, look it up, Google it. The last thing I'll ask you though, Keith, is what message can you give farmers with climate change? What would be your final message to farmers to deal with this into the future, maybe?
Yeah, so I guess first off, just to make sure we're all clear. I mean, the climate is changing, but what governments all around the world and sectors all around the world have all realised, it is difficult, it is annoying, and it could genuinely be very hard to change practices. But the reason governments all around the world signed up to the Paris Agreement was because, in recognition of these massive changes facing them, they all realised that the cost of inaction is far, far greater. So that's the reason change is happening. It's for the greater good. It's not to penalise anybody. Then with regards to, we looked at the models then as well. So also be mindful. So the climate models, they talk about climate change. Okay, so that's change. It's not climate doom. It's that's change. And you've already touched off some of it in the sense that we're expecting to see rainfall patterns change on average. That's not to say it's going to happen every year, but on average into the future, we expect to see rainfall patterns change, where we see maybe more heavier rainfall events in the winter and maybe more prolonged, drier summers. So that comes down to water management problems. So the advice I'll give is look for opportunities in the signals as well. It doesn't all have to be bad. If we know these changes are happening, the climate science is effectively giving us the benefit of hindsight. If we're able to plan ourselves now and start to plan for, well, if you know these changes in rainfall patterns are likely to happen, well, then maybe we should start to think about water management in a bit more. Is there ways of capturing water better during winter months and be able to use that during summer months? We also know that the temperature is changing, okay? So temperature is changing, okay? So we're expecting to see probably more heat stress and so forth, which is a bad thing. But on a positive note and more of an opportunity note is that temperature is one of the primary triggers for grass growth. So we're also expecting to see that the growing season also increase as well, which can be a positive. Because things are getting warmer day and night, we're also expecting to see less frost days. So this also opens the door to opportunities. So I guess the advice I kind of give is don't necessarily treat change as a bad thing. Change is change. So try and look for the opportunities within that change in order to make the best advantage of what we expect to come into the future. Now, if I just finish, Cathal, on that note, I know fairly often as you do, I'm talking about the weather and climate literally day in, day out, even on my days off. And sometimes people kind of feel a bit nervous of this change. I even heard a new phrase, which I hadn't heard before recently, climate anxiety, particularly in the young, which I wasn't even aware of. And people, understandably, are kind of getting worked up and curious about this. But if I finish briefly on a story, and it's a good news story, it's a story of ozone. Do you remember the ozone hole, the ozone layer?
Yeah. Kids, it was everything was ozone that time. Yeah.
You remember that? We don't really hear about that much anymore, do we?
No.
So what happened back in the 1970s? Scientists discovered that there was a depletion in the ozone layer, and it became known as the ozone hole. And what they did was, through measurements, they identified what the problem was. It was the release of these CFCs, or chlorofluorocarbon, or these ozone depleting gases into the atmosphere. And what they did was they managed to convince decision makers and policymakers all around the world to create a legally binding international treaty. It's called the Montreal Protocol. And this protocol and subsequent amendments led to action, that action being the reduction and eventual banning of these CFCs and other ozone depleting substances. Now, because of this, that has led to the prevention of an environmental catastrophe. And I'm happy to report that measurements made by Met Eireann and others around the world, that the ozone layer, the depletion has begun to level out, and we're expecting it to recover, and a full recovery later in the century. So it's a good news story. Now, think of the stark comparisons to the climate story. Okay? Scientists discovered that there was a problem. The Earth was warming up through measurements. They managed to convince politicians of what was causing it, the additional greenhouse gases. Those politicians and decision makers came together to create a legally binding international treaty, the Paris Accord. And we're now moving to the last stage of action. We're actually beginning to take action in order to prevent this environmental catastrophe. So we have already proved as a human race that the template works. We've already done it. We're now well into the climate template. We've proved it worked in the past. So fingers crossed, in our warming world, we can do it again.
Yeah, and that's a really brilliant note to finish on, Keith, because I think if one thing people are good at is when they have a problem, finding a solution. And look, the Teagasc MAC curve is there to tackle climate change and greenhouse gases, and that's available to everybody who needs to see it, and all farmers. So thank you very much, Keith. That was a really good conversation today.
Pleasure. Thank you.
It was really good to chat with Keith today on the podcast. And from it, I've taken that the Met Eireann site is well worth a visit. It has specialised services for agriculture and the environment with numerous useful decision-making tools for all. Apart from the rainfall and the temperature data, they have many useful resources on soil moisture deficits, grass growth forecasts where they've collaborated with pasture base, information on best opportunities to spray, information on field conditions and trafficability, and their warning information is also extremely useful.
Yeah, just on that, Deirdre, we're just after coming out of springtime now, and just if we're thinking of tools that we'd often advise farmers on for spreading early nitrogen. Now I know we're gone beyond that, but some of the big ones we would say is look at the soil temperature. We're always looking for that 5.5 degrees. The soil moisture, we're looking for that, and obviously if there's any heavy rainfall within 48 hours. So the tools are brilliant, and even you have their likes of blight warnings and stuff like that. So it's well worth a visit.
And also, I suppose, we have the daily, the weekly forecasts, and Keith has told us that into the future we'll have even longer range forecasts.
Yeah, and it's specific to farmers as well. It's actual farming forecasts. And there is a unit within Met Eireann that are actually completely dedicated to agriculture and meteorology.
That's it for this episode of the Teagasc Environment Edge podcast. Thanks to Keith Lambkin, Senior Climatologist with Met Eireann, for joining us on the show.
Don't forget to rate, review, and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify. And for more information, go to the Teagasc website at teagasc.ie. I'm Cathal Summers.
And I'm Deirdre Glynn.
Join us next time for the Teagasc Environment Edge podcast, signpost to farm sustainability.